and thank you for joining in. Small mishap, but could you just confirm if everything is working as expected with respect to the video and audio so that we can get started? Just to see how it's working. Everything looks good at my end. Again, if you're not seeing the chat window, just refresh the page, you'll be able to see the chat window. So if everything is looking good, we can get started with the actual session itself. Is there a glitch of any sort? Okay, so everything is good. Okay, since everything is good, we'll get started by 7:02 or 7:03. So I'm happy to take maybe one or two questions now, since we have the session after solving a few problems. I'll again participate in a general Q&A. Doing masters, can we join as a faculty in any college? Again, it depends on what college you're planning. Colleges of India, it is better to have a PhD, because for faculty positions, if you want to grow, PhD is obviously a better option. Join as a faculty member after masters, preferred degree if you want to build a career. So this is a question from Shavik. Cool. Again, after GATE, after you PhD, that option always exists. Everything is looking good, no issues. So we'll wait for some more time for everyone to join in. Today we'll be doing some questions on virtual memory. So I'm a fourth year student placed in a startup. Because of health conditions, I'm not able to give for GATE what to do. So my suggestion is, Ankit, if there is a healthcare situation or if there is a family emergency, I think that's something that you have to look into immediately next year. But if your family needs you, or if you need medical help, that should be your top priority. It's okay. Focus on that, because if that always beats anything else, right? That should be your top focus. And since you already have it, is there a buffering issue? I'm connected to my fastest network. Let me just check. Some of my team is saying that there is a buffer. Just a second. Let me just check, because this has not happened with YouTube. Okay. Just give me a second. I'm just testing my speed. I'm connected to my fastest network. Fast.com. Getting like 380, 400 Mbps. So I don't see an issue. Yeah, I'm getting like 330 Mbps. So no major issue on that front. One second. Let me see what else can I do, which is OBS. The kbps are stable. Page and see how it's working out. Let me start sharing my screen quickly. Okay, so I'm sharing my screen now. I see that my 30 FPS, right? I'm connected to a 5. Let me just check my speed. 260, 250. Let me just check it again. Yeah, just 6 Mbps to 8 Mbps is. Just give me a second. I'm seeing what is wrong. Just give me a second. What else can I do here? Go into my settings. I haven't changed any settings per se. Or else let me see if there is some process on my computer that's eating up a lot of CPU cycles. I'll fix it quickly. Nothing that is alarming. Is quite low. What about memory? Okay, I've closed most of the apps that I have. Just quit. Let me quit Xcode. By any chance, it's still buffering. Let Let me see what else can I do here. No, my internet connection is fairly stable. It typically, I don't know any issues. I don't require a lot of bandwidth. It's doing 2 to 3000 kilobits per second. 1 second. There is still, again, my team is telling me that there is. Let me just check my internet speed again. Yeah, I don't see any issues with internet speed per se. Okay, so let's do one thing. If this is not looking good, I don't know what the problem is. At least because I just looked at my RAM utilization is all right. My CPU, it's not throttled. Work. Network is okay. So packets out per second. Just give me a second. I'm seeing if there is a problem at my end. If there is a problem at YouTube end, probably I'll not be able to fix it. YouTube end, probably they'll take a few minutes to fix it. Can you guys, again, one of the students is saying it's looking all right now. So can you just cross-check that now? Let's wait for a couple of minutes and see. Kamal is saying that everything is looking. My phone once quickly. Give me a second. Okay, 1, 2, 3. Is it seamless now? I'm just trying to speak something and see. No, this is something is wrong. I don't, again, on my phone itself I see hiccups. So let me see what my phone is connected to just to be. Just give me a second. I'm just trying to figure out if there is something at my end. Yeah, Deepak, the problem is the problem with restarting live is, okay, let me give it a try. But simple word of caution here, because I've tried this a few times earlier. When I try to reconnect to YouTube live, sometimes the older live session gets terminated and I'm not able to reconnect. If that happens, we'll just in case that happens. Okay. So just trying to see. And let's see what happens then. Sorry. Okay, I have reconnected back to the same stream. Is there any luck now? I'm just reconnected to the same stream. Thankfully, the stream is not dead now. So let me also check on my phone quickly. Sorry for this glitch, folks. I have not experienced this earlier. So I'm also a little clueless. I've had instances where my system goes down, my internet goes down. Is this better now? Okay, I'll just count 1, 2, 3, 4, 5. How is the experience now? Can you just refresh, folks, and let's see how this works? I just reconnected. iPhone. Okay, it's good. Okay, cool. Okay, sorry for this glitch. Again, I often try to join forcefully to avoid these glitches. It's not yet okay. Can everybody please refresh and let's see how this works? I'm sorry for this glitch, but I don't know what to do at my end. Okay, it's fine now. Again, till the time it's stable and fine, because in the question answers we need more interactivity for sure. So I'm just trying to. It's fine. Okay. Okay, so this is good. Okay. Okay, this seems to be, is there a glitch again for somebody? Come on. Okay, I'm just trying to see it on my computer and just give it a second because I believe some students are still facing a glitch. So 1, 2, 3, 4, 5. Because I can't turn on my phone's audio because it will create a feedback loop. Yeah, there is a few seconds delay, but okay, the mentors are also saying that it's looking okayish on their end. So let's get started then. I'm sorry for this delay, but okay, I'll spend some time just answering some of the questions here. Maybe 3, 4, 7:15 we'll start the Q&A. So I hope it stabilizes for everyone. Okay, cool. Let's hope it stabilizes. If there is a huge glitch while we are solving it, mentors, please let me know. I'm looking at the chat window. Students also, please let me know. If there is a major glitch, we will just reschedule it probably to tomorrow. Don't worry about that. Okay, cool. So Shoaib has this question, which is, should we revise topic-wise or subject-wise? Again, instead of doing topic-wise or subject-wise, I mean, you can do either way. There is no wrong way to do revision as long as you're doing revision. But another way of thinking of intervals of time, do it weekly, do it monthly, do it every 2 to 3 months. If required, do it every 2 weeks. So doing it at regular intervals is advised at the end of the week and things like that. But at the end of the day, if you do topic-wise revision, it could become little overwhelming for you. But if you have time, please go ahead, do it. But certainly do revision subject-wise. That is mandatory. Okay. Can others confirm? Is there still a problem? Is there still a problem, folks? Again, I'm just waiting because I see a lot of people saying frame dropping. Okay, let's do one thing. Instead of creating a bad experience, I don't know what the glitch is because I don't want to restart my computer because the YouTube live will be dead by then. Right, so let's... okay, fine. So since our team is saying let's continue, I'll go ahead with it. Again, let's try our best, okay? So I'll answer the questions at the later part so that we can have more interactivity. Let's get into the questions itself right away, right? Because in questions, I don't have to do lot of talking, especially when you're solving the questions. Let's go ahead. Let's see how it pans out. Worst case, we will reschedule it to tomorrow or the day after. Okay, cool. So I'll start sharing the screen and let's go in. Okay, so today's live session is all about virtual memory, very important and interesting topic. So let's get going, right? So here is our first question. Let's solve some interesting questions across the spectrum of easy, medium, and things like that. And here is our first question. Again, I can see this question on my phone. This is a 1-mark question. Again, I will surely answer some of the general questions that students are posting. I'll answer many of them in the later part of this session. For now, let's focus on solving the questions and let's solve these 5 interesting questions, some easy, some medium, some little tricky over the next 45 minutes to 50 minutes. And then I'll surely come back to the questions and I hope the stream also stabilizes by then. Again, it's an MSQ as it's mentioned here. Simple question, fairly simple question. simple 1 mark question, like a warm-up question, right? It's literally a giveaway. Most of you got it right, couple of you probably missed it, so just read it carefully. Again, some of you have questions about placements. I'll surely answer that at the end of this session. Let's solve the questions. I'll make sure that I answer the specific question about balancing between placements and gate. I've mentioned this multiple times in my previous sessions also, but there is no harm in repeating given that students' placements are starting now. Okay, I think most of you got it right. So let's go through this, right? So this is a segment table. This is the segment number that we have. This is the base address, and this is the length of the segment, right? So, and you're given these 4 addresses. In each of these addresses, the first one is the segment number. The second one is the offset. So the question here is, which of the following will there be no illegal reference error? So if you look at this, this says segment 0. And it says the offset is 430. So whatever is the base address, you will add 430 to it, right? And now, since the length of the segment itself is 600 bytes, the 430th byte in this segment can be found, right? So there will not be any error with respect to this reference, right? So if you're referencing this address, which is segment 0 and offset 430, there should be no issues. Similarly, if you look at option B, sorry, this says segment 1, so this segment, and it says offset is 10. So segment 1, the base address is 2300 and the length of it is 14 bytes. And now you want to access the 10th byte in this segment. And since there are a total of 14 bytes, it's perfectly valid address, right? So this all B also no problem. It will not create any error. What about C? If you see C here, this says frame 2. It says segment 2, I'm sorry. It says segment 2. In segment 2, it says the offset is 101. The base address is 90, perfectly all right, but the length is 100, right? Which means if you're trying to reach to the 101st byte, right, you basically take the base address and add the offset to it. If you add it, what you have, whatever address is the resulting address, it will not belong to the segment. So this will create basically like a trap, right? This will basically create like a trap-like interrupt. Because it's faulty. You can't access, you're a user process who is trying to access this, and you're not allowed to access it because, I mean, there is no address location 101 for segment 2, because there are maximum of 100 bytes. The total length itself is 100 bytes. How can you go to 101st byte, right? So this will create a trap to the operating system. So this will create an error or an exception or a fault, right? So next, let's go to the 4th option. So C is certainly, you will not take it. What about D? D says segment is 3, right, and the offset is 400, and the total size is 580 here, right? Base address is cool. The total size is 580, so you can always go to the 400th byte there. So D also no issues, right? So you can comfortably, I mean, there is no issue here, right? So you have A, B, D as the answer. Some of you said slightly different answers, so please cross check that. This is a very simple giveaway question, literally a giveaway question. Okay, so cool. With that, let's go to slightly more interesting questions, right? This is like very simple. So this is a typical 2-mark question in GATE. Okay, this is very typical of questions related to paging, virtual memory and things like that. Very typical question in GATE. Again, we have also solved tons of these problems in our course videos, previous year questions, etc. Again, Aniket is saying for the previous question, is this what is called a segmentation fault? Yes. Segmentation fault does happen whenever you write C code or something. If you're trying to access some memory location which you're not allowed to access, right? That creates a segmentation fault. Yes. Somebody asked this question in the chat window for the previous question. Sorry, let's solve the second question now. Please be careful with this question. Given that it's an NAT, we see a lot of students making mistakes in such questions. Intentionally, such questions are given as NAT so that you can't guess or eliminate things. You have to solve it. Take your time. Please avoid silly mistakes with this. Work out step by step what's happening. The question should be in nanoseconds, folks. It says dash nanoseconds. This is very, very typical of gate questions. Yeah, if you know the concepts, it's easy, to be honest with you. If you know it, but typically we would still rate this question as medium by gate standard because we see a lot of students committing mistakes here. But if you know the concept, when we solve it, you'll see that it's actually easy. Please use a calculator, whatever helps you. Yes, you will get a virtual calculator during the gate examination. Yes. Mallikarjun, please try to post your answer. sorry. Yeah, so as one of our mentors is saying, sometimes gate also does consider a range of values within some, like they might say, hey, from this range x to x plus some delta, we will consider as the right answer. Sometimes, not always, sometimes. Let's solve it together in a couple of minutes, but I'm just waiting for everyone's answer. Rishabh, please post your question at the end. I'll surely answer it. There is a reason why we don't have quick revision lectures because, anyway, let me answer it. But others are solving it. I don't want to disturb them. I'll solve it later. I'll answer your question a little later. Let's focus on solving the questions. Please post your question at the end. I'll surely answer this. Okay, we have spent good time, so let's see what happens typically, right? Whenever you have an address, right? Whenever you want to address something in a paging system, you have the TLB cache where you're trying to store, which is much faster than having the page tables in the main memory, right? We've discussed this in our course videos in lots of detail on why we need TLB cache and details like that. So what we want is effective memory access time. But we have to be careful when we construct it, right? So effective memory access time in this case, let's go step by step, right? It says that the page fault rate is 1%, right? Which means the probability the page doesn't exist in the main memory, right? So page fault rate is 1%. Okay, cool. And the page transfer time from disk to memory is 1 millisecond. Okay, cool. So disk to memory, anything that I have to get is 1 millisecond. Since everything else is in nanoseconds, let's get this in nanoseconds. So you have 1 millisecond is 10 power 6 nanoseconds, right? Because you have micro between, right? So 1000 nanoseconds is 1 microsecond and 1000 microseconds is 1 millisecond. So 10 power 6 nanoseconds. One level page table, simple. Cool. The main memory access time is 200 milliseconds. Okay. So, sorry, 200 nanoseconds. I'm sorry. We further assume that the TLB is used with a TLB hit rate of 90%. Okay, good. And page fault rate is 1%. Okay, so page fault rate. Again, I'm just trying to place all the values here. Sometimes I also just underline them so that I don't miss any of these. And the TLB access itself is 20 nanoseconds. Okay. So now to compute effective memory access time, right? So there is a 90% chance that, okay, so let's break it down, right? So 90% of the times what happens, we will just go to TLB, this cache, we will hit it. So it takes 20 nanoseconds to hit this. And then we directly go to the memory location and obtain whatever data we want. So TLB cache and then directly go to the main memory, all the data that's there in the frames of the main memory. So 200 nanoseconds for that. 90% of the times this is what will happen. Now 10% of the times what will happen? Let's look at that, right? So 10% of the times, let's see what happens now. 10% of the times, okay, two things can happen. Your data is already there. See, 10% of the times when when there is a TLB miss, the page table, you might have to use the page table that's there in the main memory, and then you will fetch data from frames, right? But to do that, first you would check in TLB, right? So, okay, again, there is one more thing that you have to remember, that there is a 1% chance of page fault. So within this 10%, there is a 99% probability that there is no page fault, okay? And there is 1% probability that there is a page fault. We just write all these steps, right? With it, again, 90% TLB cache hit, right? And again, remember, it also says those pages which in the TLB do not result in any page fault, right? So everything that is there here, no page faults. Everything outside that, everything that is not there in TLB, only those have page fault, and 1% of them have a page fault. 99% of them don't have a page fault, which means for 99% of them, we don't have to worry about disk. So for 99% of them, first we would have gone to TLB cache. We would have spent 20 nanoseconds checking on TLB cache, and we recognize that there is a miss. Then we go to the page table that's there in the main memory. For that, we would require 200 nanoseconds. And then we will actually fetch the actual data from the frames, from the physical RAM, right? So 200 nanoseconds for that. So this is the total time whenever there is a TLB cache miss, but everything is there in the main memory, which means there is no page fault. 1% of the times there is a page fault. So let's look at all the steps that happen there. First, there is a TLB. First, you go to TLB, there is a TLB miss, right? Then you go check for the page table in the main memory. You're spending 200 nanoseconds again for that. Here it says, hey, the corresponding frame is not there in main memory, which is what created the page fault in the first place, right? Then you go to the disk and you say, hey, fetch this data from the disk. That is 10 power 6. Once the data is fetched into the, so once the data, whatever data we want, once it's fetched from the disk, again, it's placed in the main memory. We have to fetch it from the main memory, right? So 200 nanoseconds to fetch the data from the main memory. This is our total time. Now, if you see this, this is 0.9 into 220. So if you use the calculator, 0.9 into 220 would be about 198, if I'm not wrong. Yes, it's exactly 198. Then 0.1 into 0.99, right, which is 0.099 into this whole thing. This will result in 41.58. Then 0.1 into 0.01, which is 0.001 into this whole expression. If you simplify this, you will get 1000.42. I think these numbers have been carefully chosen so that they sum very gracefully to 1240. That's it. Is there a problem with the calculator or anything like that? Let me just check. So 0.9 into 220 is 198, right? So 0.9 into 220 is 198. We got that perfectly. The second thing that we have to check for is 0.099. So this 0.1 into 0.099, right? So that will be 0.099 multiplied by, this is 420. So let's multiply it with 420. This gives us 41.58. So 41.58. The third one is 0.001, right? Because this is 01, this is 0.1. So 0.001 into, this is 1 million, right? So which is 1 followed by 6 zeros, right? 1 followed by 6 zeros, and then this is 420. So the last 3 digits will be 420. Okay, if you do that, you get 1000.42. If you sum up all these, right? So again, let me just do that to be sure, because some of you are getting a slightly different answer. 41.58. I just want to make sure that I have not made a mistake. Yeah, this is exactly 1240, right? So very simple. Again, the steps are very simple. I'll just quickly recap these steps for you. Okay, first 90% we'll have everything in the TLB cache. So 20 milliseconds to find whatever is the corresponding frame, and 200 milliseconds to access the data from the actual frame in the main memory. Done. This 90% is taken care of. 10% chance that we have a TLB cache miss. Within that 10%, again 99% that there is no page fault, 1% that there is a page fault. When you have a page fault, when you don't have a page fault, you've already spent 20 milliseconds to find that there is a TLB cache miss. And then this 200 milliseconds is to access the page table that's there in the main memory. This 200 milliseconds is to actually fetch the actual data from the RAM, from the frames. When you have a TLB miss plus when you have a page fault, because it clearly says for those pages within the TLB, they don't result in any page fault, right? So this 1% of the times you have TLB cache 200, the page table lookup, which is 200, copying the data from the disk, which is 10 power 6, and finally accessing the data from the frames itself, right? So the exact answer is 1240. Very often in gate, they try to, again, not always, I mean, because they could say, hey, round your number to 2 decimal places, and that could confuse some of you. You just have to do it carefully, that's it. That's why I said this is an easy problem if you know the steps, but we see a lot of students making silly mistakes. In case, just imagine if they said round your answer to 2 decimal places. All the people who have said 1240.00 would get the marks, others may not. Right? You have to do it carefully, step by step. Think of the flow. Again, the reason I've drawn this, right? The reason I've drawn TLB cache, within main memory, you have the page tables and you have the frames, you have disk. This sort of gives me the visualization on the flow. Okay, you've generated an address, right? Now, first you'll go to TLB cache. Then if there is a miss, then you go here. Within this, there are page tables and there are actual frames. There is a page table. There is only one page table, right? Because it's a single level page table. And then there is a disk. So if you're just careful, I think you'll get it. That's the key. Okay, problems like this are not hard, but they're very, very prone to mistakes. We've seen a lot of students make mistakes in the last few years for similar problems. One more small thing that I wanted to mention here, in GATE 2011, right, there was a very similar question where they used a term called page fault service time. Okay, they used this term. Unfortunately, they did not define what it means. Okay, so they used this term called page fault service time. Now, okay, so just remember that there are two terms that I wanted to introduce. So there is another question from GATE 2020, which is where they use this term called page swap time. Again, the problem in using some of these terms is if they're not perfectly defined, depends on the textbook. The textbook that you have read may not have these definitions, right? Sometimes they might use the term page swap time or page transfer time. Okay, so one thing, because these terms have been used in the previous year, I just wanted to define these terms for you. Page fault service time includes main memory access time. Because it says service time, it already includes the main memory access time. Okay, and only people who did this got marks in the 2011, which is unfortunate because they should define what page fault service time is. Similarly, page swap time does not include, okay, page swap time or page transfer time does not include the main memory access time. Okay, just remember this, because if these terms are again used, it will be helpful for you not to mess it up. Wherever they say service time, think of it like an inclusive of everything, inclusive of the main memory access time. If they just say swap time or transfer time, it doesn't include the main memory access time. It just is the time to transfer or swap. I think here we use the term here, right? Where is this? Okay. So, okay, we clearly said the time taken from disk to main memory is 1 millisecond. We clearly said that is nothing but your page swap time or page transfer time from disk. Okay, so sometimes there are these, this happened only twice till now, but you have to be slightly careful with it. Okay, cool. So just wanted to clarify that. So these questions are easy, it's just that you have to be careful. Okay, cool. Again, here nothing is written about dirty pages. So if nothing is mentioned, you can assume that there are no dirty pages. Okay, cool. Okay, let's answer this question now. This is a slightly more interesting question. This is also, I would say this is a 1 mark question. Divyang, please feel free to ask your questions at the end. Let us focus on solving the questions now. As we always do, we spend good time at the end answering general questions. Again, wherever there is W, it means there is a write operation on that page. This is page E having a write operation. Just be careful. This is a good 1 mark question. Write here means you're writing to one of the memory locations in that page. It means write operation. It clearly says here, right? Wherever there is W, it means that the corresponding page was written to, some data was written to that page. Sam, you're asking a question about the write. Think about it. I will answer this when I explain the solution. Again, everyone, please cross-check your answers. While this is a 1 mark question, it's also slightly tricky. We've intentionally made it slightly tricky because we know a lot of students will commit common mistakes here. So the question is, how many page transfers happen? Okay. Okay, everyone please cross-check your answers once. I see 3 answers, 9, 10 and 11 extensively, so please cross-check. Only one of them can be correct, obviously. Or somebody says 6 also, so please cross-check. While this is an easy question, it's also tricky. So page transfer means any transfer of a page from your main memory to your swap space or disk. Right? That's what any transfer is counted as a page transfer. While page fault basically means that, okay, the page is not available, so it raises this, so It gives the control back to operating system and says, hey, I don't have this page, please fetch it. Okay, so let's count it, right? So first, we have 3 frames, right, in our main memory. We have 3 frames. It's completely empty at the beginning. So when we have this A, you would have 1 page read. So because we'll have 1 page transfer, right? Because everything is empty, right? So what we have to count is not number of page faults, but page transfers. So there will be a page transfer from disk to your one of these 3 empty frames that you have in your RAM, right, or main memory. So one page transfer is happening here. B, again, it's not available. So you will do a page transfer again, simple. C, again, page transfer. A, B, C are done. And what is the methodology we are using? We are using FIFO, first in, first out, right? Then, so what all, okay, so at this time, what all do we have? Okay, let's maintain a system here, right? At this time, we have A, B, C frames, right? Of course, A is the first one that came in. Now, let's keep a mark on that. A is the first one that came in. A, B, C are the 3 frames that we have in our main memory. Now we require, let's say we are referencing something in page D. Now page D is not there. So what will FIFO do? FIFO will simply remove this because it's the first one that came in, and it will replace it with this. Okay. Remember that there was no write operation to A. There was only a read operation. So I don't have to store this A back to my disk. I don't have to store this A back anywhere. I can just discard it because there is nothing to, it has not been modified. See, remember, I copied A from disk to main memory and I've only read from it. There is no write operation. So I don't have to transfer this page A back to disk because a copy of it is already on the disk, right? So I don't have to worry about copying. Now when I have D, I have to copy D, or I have to transfer page D from disk to main memory. Okay, so one more page transfer. Now A is not available. Again, A is not available in the 3 frames, first in, first out. So this gets thrown out, and we have DAC, right? Yeah, we have DAC. Here also this B which is there, we only read from it. There is no write operation to B. So I don't have to transfer it back to disk, right? It's not a dirty page. Okay, it's a perfectly, you just read that page, you read this page B from disk to main memory to one of the frames, and then you read some data from this to whatever process that you're using, and then you didn't edit anything. A, so with A you had one more event here, right? So then we had DAC. Okay, cool. Did I miss anything? Okay, so everything is good till now. Then we got B. Frame B is also not there, right? So now which is the first frame that came amongst these? C is the first frame that came. So C will again get replaced. C need not be transferred back to disk. So what do we have now? We have DAB. So one more transfer. This B got transferred from disk to one of the frames. Next you have E, but you first look at this. You want to write to E. This is the write operation to E, but E doesn't exist in the first place. It doesn't even exist. First you have to read E. Remember, you have to transfer E from disk to main memory. Okay, so this will get replaced. You will have EAB. Only one event, but remember that this E is now a dirty page. Let's not forget that it's a dirty page because you loaded this E from disk to main memory, to one of the frames in main memory, and you wrote to that because it's a write operation. So it's a dirty page. We should keep track of that. Okay, next you have A, write to A. Okay, so now if you observe, we already have EAB. So this A is already available. So I don't have to, I don't have to transfer any data from disk to main memory. So 0 here because it's already there. But remember that A became a dirty page again. Okay, let me use this. So this is 0. No data transfer from, again, remember you have disk, you have main memory, right? So A is already there, right? So I don't have to transfer anything from disk to main memory. But remember that A became a dirty page now. Next you have B. This is where things will get very interesting. B is already there. So no page transfer required. Cool. Next you need C. Okay. So let's see what happens with C. When you have C, C is not available in the 3 frames. We have to pick one frame and throw it out. Okay, which is the oldest frame in this? A is the oldest frame. So now you want to pick A, throw out A and load C. But remember that A is already a dirty page. Because it's a dirty page, you have to move this A from the main memory to disk because it's dirty. Right? Because you edited it, you changed, you wrote to it, you have to first do this one page transfer from main memory to disk. After you do that, then you load C from disk to main memory. So this C actually has 2 page transfers. There is only 1 page fault, but there are 2 page transfers. That is important. What are the 2 page transfers? The dirty A is transferred from main memory to disk, and C that we need now is loaded from or transferred from disk to main memory. Okay, so again let's see. So what we have here is E, C, B. Till now everything is good. Okay, next we need D. D is not available. So what do we do now? Again, we have to pick whichever is the oldest or the first come first serve. So B is the oldest, right? So we replace this B and we copy D here. So 1 page transfer. Again, remember B is not a dirty one. So we don't have to copy it from, or we don't have to transfer it from main memory to disk. We only read from B. We never wrote anything into B. Then finally we have a read operation on E. E is already available. E is already available, right? So there is nothing to be done here. So till now, how many operations have we done? There is a follow-up question that many of you will have. Okay, till now how many operations have we done? 1, 2, 3, 4, 5. How many page transfers have we done? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Till now we have done 10. Now the obvious question in your head now is, hey, E is also a dirty page. Shouldn't we write E to the disk now? No, because E is still in the main memory till the time E gets replaced by some other frame. At this point of time, our question here is, for this sequence, do we need a page? How many page transfers require? At this point of time in your series of page references, E is still in your main memory. While it is dirty, I agree it is dirty. It is dirty, but it is still in your main memory. So you don't have to write it till the time frame E gets replaced by some other, page E gets replaced by some other page. That's it. So the answer is 10. Many of you said 9 or 11. I think most of you did not count this as 2 because you forgot to copy the dirty A to disk. That's one possibility. Most of you who got 11 thought that, hey, E is a dirty page, so we should write it. No, E is still in memory. While it's in memory, why should you write it back to disk? Right? You don't have to write it. The question is, after this sequence or by the end of this sequence, how many page transfers have you done? This is a tricky question, but again, the question clearly doesn't say page faults. If you say page faults are different. If one of the pages is not available, it creates a page fault. Like for example, here there will be 1 page fault but 2 page transfers. That's the key difference. That's why I said this is a tricky question. Lot of people will make mistakes in such questions. So please be careful. Always think from first principles. Always think, the best way I would suggest is think on what is happening. What is getting transferred from disk to main memory to TLB. Think about that structure internally. Okay, cool. Yes, so nice follow-up question from somebody. Imagine if there is some other page that comes that replaces E. Then E, because it is dirty, because we had a write operation here. While we have a read operation here, there was a write operation. It's still a dirty page, right? So in your page table, in one of the bits, it says, hey, this has been written to, so it's a dirty page. So if E gets replaced, you will have to copy E from main memory to disk, and whatever is the new page that you need to, there will be 2 transfers then, right? Obviously. Cool. So let's go to the 4th question now. I've squeezed the whole question in 1 page. This was one of the most interesting questions for me today, where I was solving it just like any of you. This was a very interesting question for me. This is a 2 marks question. This was one of the good questions I solved today. I really enjoyed solving this. Please take your time. What is important is to get it right, not the speed at this point. Please think very carefully about this. It is important to prepare for all sorts of question papers from very easy to very hard, or at least hard. That way, or even tricky question papers, right? That way you're preparing for all cases. This is an NAT, guys. There are 2 code snippets given. Please read the question. This is an NAT. You have to fill this answer. Please read the question carefully. Think from first principles. Think from basics. Take your time, think through this carefully. Very important to think through carefully. I'm just drawing some diagrams to help me explain this faster. This is an NAT, so please fill in the blank. The reason I like this question is because it's in the intersection of programming and operating systems. And this is a very practical type of setup, especially when you're operating with large data sets, especially in data science and machine learning. Again, this is like a toy problem, but similar stuff you encounter in large scale machine learning where memory is scarce. Again, this question is not hard. The reason I like it is because it's close to some of the real world challenges with respect to memory management and programming. Good. I see some of you answering the question. Good to see that. Again, understanding the question itself takes a little while, but solving it is quick. Okay, I'm happy to see that many of you got it right. Just in the interest of time, because we had a technical glitch earlier, I'll solve it for you. I'm happy that most of you got it right. Again, the question, you have A, which is a two-dimensional matrix or two-dimensional array, and this is in C programming language, so everything is stored in row major order, right? So that's the first observation. Next, if you observe this code, right, and it says, hey, that you have it says you have three frames, right? You have three frames. In frame 0, you always have your code. Each frame is 200 bytes, right? Roughly about size 200, right? So you have frame 1 and frame 2 where you can load 200 integers here, right? So the first one is like a column major order. So what you're trying to traverse is, first because you have A, I, J, but the outer loop is with J, the inner loop is with I, right? So what you're doing here is, you're first trying to access these values. You're trying to access the first column values and fill everything to 0, then the second column, then the third column, and so on and so forth. Now, look at it. So let's assume first you want to access, because the order is first you want to fill this value to 0, then this value to 0, and so on and so forth, right? Now, if you observe, to access these two values in the memory, everything is stored in row major order. Let's not forget that, which means this row, this 100 values are stored, followed by these 100 values, followed by these 100 values, followed by these 100 values, and so on and so forth, right? It's as simple as that, which means if I want to access this and this, I need to load these 100 values and these 100 values, right? So these 200 values will fit in one page. Look at this. To access two values, I need one page load. right? So in this page, I will load the 0th row and the first row, because I have to load the whole row, right? Remember, I have to load the whole row because because my page is 200 bytes, page needs to have contiguous memory. So if you look at the row major order, all these should be stored in contiguous memory, right? So to just access two values, remember, to access two values, I need one page load, right? Or if you see, what is the question? I have one page fault. Okay, so when I have when I try to access this, I get a page fault. When I get a page fault, I load this whole 200 numbers. When I try to access this, I don't get a page fault because this has already been loaded, because I'm loading these 200 numbers. Next, when I try to access this, I'll again get a page fault. When I get a page fault, I will load rows 2 and 3, which means when I access this element, this is third row, 0th column, I do not get a page fault. So if you observe, for every two values, I'm getting one page fault. And this will repeat. Again, remember, this will keep repeating. First, I'll finish all of them, then I'll go through all of them. And remember, I only have 2 frames. I don't have hundreds of frames here. Because I have only 2 frames, I can look at this. I first process these 4 rows, right? Or in other words, I load these 4 rows through 2 page faults, but I can only process 4 elements. Then next 4, so on and so forth. Once this whole column is over, then I'll go to the next column and so on and so forth. So effectively, the number of values that I need to read is 100 cross 100, because I'll have to set these values, right? Again, the question is not about page reads or page writes. It is about page faults, because there is a write operation that's happening here. You're setting Aij to 0. Okay, the question is all about page faults. Don't apply the same logic of the previous question, because in the previous question, how many page reads and writes were happening? Here, this is just page faults, which means for every 2 consecutive values that we have to modify and make their values as 0, we have 1 page value. And we have a total of 100 cross 100 modifications that we have to make, which means if 2 values require 1 page fault, 100 cross 100, 10,000 values require 10,000 by 2, which is 5,000 page faults will happen. Number 1. This is, so 5,000 page faults for this. What about this? In this case, you are actually accessing not by columns but by rows. So in this case, first you load these 2 rows. Look at this. First you load these 2 rows, and then you make each of these values as 0. Right? So 200 values that you are reading. Remember, 200 values. So 1 page read. So 1 page fault it creates. For 1 page fault, you're manipulating or you're changing. You're running this loop 200 times. So 200 values are being changed for 1 page fault, which means total you have 10,000. You have 10,000 values divided by 200. So this is 2. This is 50 page faults will happen in this. The question says, what is the absolute value of the difference between them? 5,000 minus 50, 4,950. Right? So I have encountered similar problems in the past, especially, again, this is a toy example. In the real world, when you have large amounts of data that you need to load into memory, just changing the sequence of your nested loop can change a lot of stuff. I've seen actual production code with these types of mistakes when large amounts of data were being pre-processed. Okay. I don't think LRU has any major significance to this question. At least. Okay. So this question is straightforward. Again, this question is not hard. This question is just a medium level question. You just have to understand how data is being accessed, and most of you got it right, which I'm very happy about. Right? This question, the reason I liked it was because it's close to a lot of real world engineering challenges, especially in data science and machine learning, where similar problems occur with GPU video RAM. I've seen people mess up video RAM code a lot because of this. So that's it. So I don't think LRU has anything important here, not anything major. The replacement policy itself doesn't matter much here. Okay, so let's go to the 5th question now. Okay, this is like a 1 mark question. maybe a 2-mark question because it's slightly lengthy. It's easy, but it's lengthy. Again, I'll answer general questions after this question. After we solve this question, I'll answer the general questions. Three frames, right? Okay. This is just little time taking, but it's straightforward. It's a simple MCQ. You have optimal and LRU. This is just about applying the optimal page replacement and LRU page replacement and checking out which of them has the larger value, right? Straightforward question. Okay, in the interest of time, I'll quickly solve this. So let's first try the optimal page replacement, right? So we have 3 frames. First we have 1. So obviously 1 will create a page fault. What is the question asking? Page faults, right? Okay, then you have 3, then you have 6. So this is done, this is done, this is done. Then you have 7. So the optimal page replacement, I mean, because it's optimal theoretically, it will look forward and see, hey, which of them can I replace, right? So 6 is the farthest being used, right? So it will replace 6, right? So it will replace 6 and place 7 here, right? So till of 1, 2, 3, 4. 4 page faults have happened now. 1, 3, 6 and again for 7. Then you have, okay, then you have 1. 1, there will be no page fault, okay, done. 3, no page fault, cool. Then you have 6. So for 6, again you will have a page fault. Now again, because it's optimal strategy, it will keep looking forward and see which of them is being accessed farthest in the future. So it will replace the 3 here for you, right? So it will replace 3 with 6. So one more page fault that happened. Again, I think I'm underlying 1, 2, 3, 4, 5, 6. Okay, anyway, let me 1, 2, 3, again I'm keeping the tally here anyway, just to avoid confusion. Then 7, no page fault, 1, no page fault, 7, 1, no page faults. Then you have 3 here, right? The 3, what will be the page fault? 6 and 7 are being used, 1 is not used. So again, it will create a page fault here. 6 and 7 are available, so you'll access them. Simple. Just applying the optimal page replacement strategy on this sequence. That's it. In optimal, you have a look ahead because you can see the whole sequence because it's theoretical, right? So how many do we have here? 1, 2, 3, 4, 5, 6, right? So the optimal page replacement has 6. We always know, actually you can skip this to be honest, because it says the maximum number of page faults. We know that optimal will not have it. Optimal is theoretically optimal, right? Technically speaking. Now let's look at what happens with LRU. Okay. So with LRU, again, we have 3 frames here. Let's go step by step. So 1, 3, 6, 3 page faults. Okay, obviously. Then you have 7. Again, this is least recently used. So when you have 7, what happens? You need to replace one of these. Which of them is the least recently used? 1, right? So 1 will get replaced by 7. Again, I'm just counting here. Whichever I'm underlying, there is a page fault, right? So 7 is done. Next we have 1, right? So 1 is not available. So again, which of them is the least recently used amongst these 3? 3 is the least recently used, right? So 3 will get replaced by 1. Again, one more page fault here. 6. For 6, 1 second. Is there a problem here? 1, 3. Did I make a mistake anywhere? 1 second. So 7, 1, 6. Okay, let me just count. I think the count should be all right. So 1, 2, 3. I think we need to have a page fault for everything because I'm getting an answer of 12 myself because I solved it a while ago in the afternoon. So 1, we have a page. I'm just making sure that I'm not messed up anywhere. So 1 page fault, 3 page fault, 6 page fault. For 7, right, what do we replace? For 7, when we see 7, we replaced 1 with 7. Okay, that part is clear. When you have seen 1, we have replaced, we have replaced 3 with 1. Okay, so then we have seen 3. Okay, so I've just over counted by mistake. Okay, so now when we see 3, we'll have to replace one of these, right? So which of them have we seen least in the past? 6. So this will get replaced. Okay, got it. Then you have 6, right? Again, literally for each of them, there is a page fault that happens. That's how this sequence has been created. Okay. For 6, again, you have to be slightly careful. So when we have 6, which page will we replace here? When we have 6 here, which is so 1 and 7 we have seen, 3 and 1 we have seen recently. So 7 will get replaced by 6. Okay, so 7 will get replaced by 6. Then you have, 1 second. Okay, I've messed it up. So then you have 7. Okay, so I'm just going ahead by 1 by mistake. So for 7, we don't have 7 here. So which of them is the least recently used amongst 6, 3, 1, 1, right? So we will replace this by 7, page fault again. Now we want 1, but 1 is not available. Which of them is the least recently used? 7, 6, 3. 3 is the least recently used, so we replace it with 1. Then we have 3 which we want, but again, amongst these 3, 6 is the least recently used, so we'll replace it with 3. Literally for every one of them, there is a page fault. 6, right? For 6, what happens here? We'll replace which of them is the which of them is the least used? 7. So we'll replace here again page fault. 7 again page fault. So literally there is a page fault for every one of them. That's how this sequence has been created to start with. So for LRU, you will have 12 page faults. For optimal 6, the maximum is LRU 12. This is like a canonical example or a standard textbook example where LRU literally sucks. Okay, cool. So with those questions out of the way, again, I'm little surprised that many of you got this question incorrectly. So while this is an easy question, it was slightly tricky. So just be careful when somebody asks for page transfers. I think it's a new type of question that one of our teammates created just to make sure to test how you handle tricky cases. Okay. So with that out of the way, let me just change to the webcam and I'll answer questions as usual. So there were 2 questions that I marked earlier. So one is, why don't we have a revision video at the end of each chapter or at the end of every subject? We have tried that already, to be honest with you. The problem with revision videos is we tend to miss a lot. Again, in a revision video, if you say, hey, these are the topics that you need to know, when we tried to actually do revision videos, they became like full-length videos because we didn't want to miss any specific detail because missing them can be harmful for you. That's why we have these handwritten notes. Please use the handwritten notes because they're exhaustive. Everything is there, or at least 99% of the details are there in the notes. So please use the notes for your revision, and based on what concepts you're struggling, you should make your short notes. Making a revision video, we tried it, but we didn't know what to skip and what not to skip ourselves. Because for us, we want to cater to every student, and different students have problems at different places, right? So if we do a revision video, it will only be satisfactory or it will only be helpful for a subset of students and not to all the students, which is dangerous. That's why we gave you the notes so that you can write short notes, concepts you understand, You can go through them faster. Concepts you're not sure, you can spend more time and things like that. Because every student is different. That's one. Second thing is about how do you balance between gate and placement. I think I've mentioned this multiple times earlier. During your placement season, please focus on subjects like programming, data structures, algorithms, maybe a little bit of discrete math or aptitude. If the companies that are coming for placement also have some aptitude questions in their one of the interview or exam rounds, focus on those subjects so that you're not leaving them. At the same time, you're trying to make the most out of preparing for gate as well as placement simultaneously, because this is the biggest intersection, right? Similarly, prepare SQL. Right? So there are some topics which are very important to placements like data structures, algorithms, programming, SQL, some companies aptitude, maybe a little bit of operating system. Those topics, try and prepare them during your placement season, as we've always mentioned. Okay, so that's one suggestion that we give you. Okay, so with that, I'll start tackling other questions. Okay, our mentors are also answering some of the questions, so I hope we answer as many as possible. Okay, so Junaid says, I'm a 2021 pass out. Is it okay to join a company? Because if you don't get a good gate rank, it will be a waste of the year. Yes, please join a company, and that's a better suggestion. You can always prepare while working for the company, and if the company has some bond, I think you can work with the HR, or you can break that if required. Right? So world isn't collapsing. So Sam says revision tends to become boring. How to make it easy to revise? The best way to revise is quickly go through your notes, quickly scan through your notes. Again, you should be able to revise a whole subject in about 3 to 4 hours. That's what we strongly recommend. Write your short notes or write your highlighting on the notes that we give you, such that you can revise a whole subject in 3 to 4 hours. Then solve problems. Revision through problems is the least boring and the most effective way. The reason we do these live sessions is to make sure that students follow a specific regimen and be disciplined in their learning. Because 99% of students who are preparing for GATE are not disciplined. What we want to inculcate is that habit of actually preparing a bunch of topics, solving some problems on regular basis. So before people come for some of these live sessions, many of them revise these concepts, solve some of the practice questions or previous year questions, and come to these live sessions. That is the important part. The best way to revise is to solve problems. Of course, revise the short notes, revise the mistakes that you have made. Apart from that, to make it less boring, solve problems. Nothing beats that. Okay, so Shruti says, I'm getting anywhere from 45% to 85% in practice tests. What shall I do? That's a huge variance. I believe that the fact that you're getting good marks in some subjects and some topics means that you have the problem solving ability. Probably what you're lacking or where you're making mistakes is mostly silly mistakes, or you're not absorbing a whole topic before you tackle the practice test. So if you're getting on the 45-50 range of a practice test, debug each of the questions on where you're committing mistakes, because most likely it is not your ability of problem solving, but it is either your conceptual gap or silly mistakes. I strongly have a gut feel that if you retackle all the mistaken questions which were erroneous, you can easily go from that 45 to 65, given that you're getting 85 marks in some practice tests. Cool. Okay, so this is from Shruti Sivakumar, who says, after clearing GATE and working in a service company, can we join PhD as an external candidate in IISc? So IISc has very, very limited external PhD intakes. It's literally, I think, one or even in very, very rare cases, they take external PhDs, because most of their PhDs are full-time PhDs on campus. It's only in very rare situations, people who are coming from government organizations like DRDO, ISRO. I've seen only a handful of candidates, literally a handful of candidates. Like I've seen a couple of people during my time at IISc. Most of these people were like 10 plus years experience in the industry, and their companies were sponsoring their PhD. And IISc is very, very selective on picking those candidates, because they're not going to spend full time on campus. They're going to go for regular work. So we had somebody from HB Research and another from, I think, IBM Research with like 10 years plus experience, who have been external research candidates, but it's not, it doesn't happen very often, to the best of my knowledge. Again, things may have changed now, but this is from my own little experience. Cool. Okay, Aman is asking about reliability engineering and SDE. Again, reliability engineering, again, the role itself could mean a lot of things. Is it reliability of software and distributed systems, or is it reliability of computer networks? So reliability engineers, again, I've seen both types of reliability engineers. I've seen reliability engineers who work on data warehouse, on data centers, working on the networking, the systems part of things, the networking or the operating system type of things. There are also software reliability guys who work on like virtualization, containerization, Docker, Kubernetes, all of that stuff. So if you have to choose between reliability engineering and software development, I would recommend that you choose software development unless you are very passionate about reliability engineering, because software engineering is much more generic, right? An SDE role is more generic. As an SDE, you can do reliability stuff. I've seen lot of SDEs who probably not on the hardware front, but certainly on the distributed systems front, reliability is something that most software engineers incorporate into their software design, into their system design or high-level design. So you learn most of the concepts of reliability engineering or building scalable, reliable systems as a software engineer. So why bother about being a reliability engineer when the scope is bigger with a software development engineer? Again, this is from my limited experience at companies like Amazon. I'm sure other companies might have different types of reliability engineering. So, okay, this is one of the students who says, I'm a 5th semester student, which means a 3rd year student. I'm getting 50 marks in grand tests by completing 75-80% of the syllabus. What can I do? Simple. Finish the rest of the 20-25% of the syllabus, because if you're getting 50 marks with like 75% of the syllabus, you're on a good track. You're getting like 60 to 70% marks. Why don't you finish the rest of the 25-20% of the syllabus you're still left with, because you have time at your disposal. You have like close to October, November, December, Jan, Feb, close to 5 months now. Finish the 20-25% of time and then go back to grand tests. I'm hoping that you'll be more in the 65 to 70 range. Push it, you can push it to 75 plus range. Okay, that's the best strategy. Again, if you get a good gate rank in 3rd year, you don't have the pressure of placements or gate next year. I was lucky to be in those shoes. In my 3rd year BTech, I got a decent rank that I said, okay, I got like a 176 rank and I was fairly happy, chill. Like 4th year preparation was chill. I was just focusing on areas that I was lacking, and things went very well for me in 4th year also. Okay. So I didn't understand. Again, please try to be a little elaborate in your question, because I'm missing some of these things. Can you just please check that? So I've reached, I think Pratik, you meant I've reached engineering math at 50% as our plan. So what should be my next plan? I don't know what other subjects you have finished, right? So it's good that you're doing engineering and discrete maths because its weightage is good. But just make sure that, so you're saying according to our plan, right? According to our plan of topics that we give you. Perfectly all right. Just continue on that flow. 5 months is good enough time. You can comfortably finish if you have reached like 50% of engineering math in our sequence of topics that we recommend, the sequence of subjects that we recommend. You're doing pretty good. Don't worry. Just follow that. Continue. Move ahead. Probably you want to speed up a little if you can, so that in the next maybe 3 months you can finish the rest of the subjects and spend the last 45 days or so primarily on revision and taking full length tests. Cool. Next thing is I have rank, this is from Abhishek. I have rank 867 in GATE 2021 in my 3rd year. Which colleges I might get? Again, I think you might get universities like IIIT Bangalore, IIIT Allahabad, surely I think IIIT Delhi, and some of these other NITs. I think you can get some programs in NIT Trichy, NIT Surathkal, etc. But since you're in third year, why don't we improve that, go from 800 to probably 80, right? So that more doors open for you, right? Again, it's good to see that you got a pretty good rank even in your third year. You can surely push it forward in your final year. Just make sure you're not losing the track. You'll get some decently good colleges, but you're still not at the place where you'll get the top IITs or IISc and things like that. So this is from Anirudh, who says, I have done data structures algorithm, CN and DBMS, and I'm an ECE student. How many hours should I put in? I think given that you have a lot more, again, you've covered some of the topics, good, like these are big subjects without doubt. DB, CN, data structures algorithms are big, but you still have a lot of turf to cover. So I would recommend that you start spending, if you're spending, let's say X hours now, probably you want to speed up. Again, make sure that you are on track to complete everything by late December, worst case early Jan, so that you at least have 1 month of solid second iteration revision and exams, right? I don't know at what rate you're going through the content now, but realistically speaking, I think if you're an average student, you should plan to spend about 5 to 6 hours now. I mean, I'm just talking about an average student. Your numbers might differ. I've completed C, DBMS, CN, OS, and COA. That's okay, Aman. You're decently on track. Just make sure that you write a detailed plan, week by week plan for the rest of the subjects, so that you can complete everything by maybe early December. So Kallol says, what is the eligibility criteria to join your company to teach GATE aspirants? Certainly a good GATE rank, that's more or less mandatory. Of course, having even if you have a slightly larger GATE rank, we have a very rigorous interview process where we focus on 2-3 things. One is how we let you pick a couple of subjects of your choice, and we go full depth on those questions. I mean, we actually give you questions on those topics harder than GATE, and we expect you to solve them in a reasonable amount of time. We also look for candidates who can explain concepts well. We have the patience and we have that mindset to explain a concept well. These are the couple of requirements that we have to join our team for GATE. So cool. How to decrease silly mistakes? I think we have mentioned this multiple times. First thing here is whenever you commit a silly mistake, make a note of it in your short notes. Revise it as part of your short notes, because I used to commit tons of silly mistakes. Today in one of the problems, right, I actually made a silly mistake. So there was this problem with the 2-dimensional array, right? So I thought that, like when I was reading it, for some reason I thought each page was 100 bytes and not 200 bytes. So I was getting a different answer. So I called one of our mentors and said, hey dude, I think your answer may be incorrect. And I tried to explain him. I said, Varma, you assumed that the page size is 100 bytes while we clearly mentioned it's 200 bytes. So the lesson from that for me, I've made this mistake myself today. While solving the questions myself, I made this mistake. And the lesson for me is all the numbers, underline them. Because I used to commit a lot of mistakes like this. I've decreased significantly. Okay, now if I were making like 10% silly mistakes, now it's like 1, maybe 2% silly mistakes. But I make a note of it. I don't forget these silly mistakes, because I make a note of these mistakes and I try to avoid them the next time. I make it part of, like when I study this subject or when I study something similar later, in my short notes of mistakes that I often commit, I just make a note of it, right? So that's the best strategy. Cool. So this is Ali who says, I want to do a PhD instead of an MTech. What will be a good rank for IIT or IISc? I think most IITs and IISc, they have a screening criteria where, if I'm not wrong, most of them will say, hey, anybody less than some 500 rank or 800 rank, you can apply for the PhD. They'll ask you to come for a examination and interviews. And in interviews, they ask you, hey, what is your topic of interest? And they will go, like if you say, I like operating systems, right? They'll go full depth on operating systems. Or if you say, I like discrete math, they'll go full depth on discrete math. So most PhD, this is true for IISc. I think this is true for a lot of IITs also, that they typically have an examination and a bunch of interviews before they shortlist candidates. It's not just based on the gate rank. And I think if you're below 500 gate rank, there's a pretty good chance that you'll get into one of these PhD programs if you perform well in their screening test and also their interviews. Cool. I think there is a repetition of questions. Okay, I think, yeah. Again, mistake book is simple. I literally take, so what I do is this. I'll tell you what I do. Everybody has a different strategy. The notes that our team has written, I have it in soft copy on my iPad. And all the mistakes I do, all my short notes, I just highlight on top of it. I literally scribble on it on the right. Any large mistake, I put a star and I say, silly mistake, and I write it there. So next time I go to the topic, I revise the topic, I know that I made this silly mistake last time. I literally use the same notes like everybody else. I just annotate it. I don't even highlight much because I can quickly read through these pages. I've learned this skill over a period of time. But the silly mistakes part and or something that I missed, something that I don't understand the first time, something that I need to rethink. I also draw a lot of additional diagrams myself. Again, a lot of the diagrams in our notes are there in our lecture videos themselves. But anything that I have a misconception, I try to draw diagrams. That's it. It's as simple as that. Cool. Yes, Pavitra, yes. I know Professor Jayant, phenomenal professor at IISc, teaches databases. His course is one of the most exciting courses, but unfortunately, I did not take his databases course because when I joined IISc, I was very sure that I wanted to study machine learning and AI. So I ended up not doing many systems courses. I did a couple of systems courses that I had to do, but I didn't take Professor Jayant's course. But I've heard tons of talks from him. Very informative talks, very real world talks. Like for example, I remember in one of his lectures, he mentioned how to read a research paper. And it's also there on his technical blog, on his official blog at IISc on how to read a research paper. I mean, there are great lessons beyond just classroom that we learned from him. And his assignments, his course is often talked about by first year students because it's both challenging, interesting, and it's fun. I mean, it's very, very involved course. Okay, cool. Sounds good. So with that, I'll wrap up today's session and see you in the coming week. Again, all the course enrolled students, see you the coming Friday for the next live session. Thank you, folks. Bye-bye. Sorry for the initial glitch. I still don't know what happened in the first few minutes where there was a buffering issue. I still don't know because my network, my computer, everything, my streaming engine, everything was working all right. Probably just a glitch somewhere, and thankfully it got resolved. Okay, see you the coming week. Bye.